Hello friends, today we'll be looking at LeetCode problem 1137, which is the nth Tribonacci number. So now the Tribonacci number is a sequence where the first number is 0, t of 1, or the second number is 1, and t of 2, or the third number is 1. And then the next number, or t of n plus 3, is calculated by adding the first three numbers. So that is t of n, n plus 1, n plus 2, and so on. So that means if I go to my whiteboard and if I just draw the list out here, so we have a list this way. Now if I say this is 0, this is 1, this is 2, 3, 4, and you're saying that this is 0, this is 1, this is 1, and now this is calculated by adding this plus this. So that will be 2. This is done by adding this plus this. So that will be 4. And 5 would be this plus this, or 7. And then 6 would be this plus this, so that would be 13. Now, in this problem, what we can do is we can make use of dynamic programming. Either we can initiate a table where we can just keep track of all the values that we are calculating and keep plugging them in, or we can just make use of 3 elements. So that is just this and this. So that is just 0, 1, and 2. So since there are 3 values that are already provided, for calculating 3, 4, 5, 6, we can just keep reusing these values. Since this value 0 is calculated by adding these 3, so we can just plug that here. This is calculated by adding these 3, so we can just plug that in. And then this is calculated by adding these 3 values. So we can also plug that in. So what we can do is, and we can just initialize 0, 1, and 1 here. And for 3, the sum is 2. So we can say that if this percentage 3 is 0, then I can just plug that out here. 4, since 4 for modulus 3 is 1, I can simply plug that out here. And then for 5 modulus 3 is 2. So I can simply plug 7 out here, and so on. So we only need 3 spaces. We don't need more than that. And also the problem states that there are only 38 values of n that they're going to be providing us. So this can be solved in actually O of 1 times complexity and O of 1 space complexity. So let's start coding this problem. So what we have to do is we have to just write off the edge cases. N is 0 or n equals 1, we return n. If n equals 2, we return 1. So that's the hard-coded values that we're going to return. Now what we're going to do is we're going to initialize a table which has only 3 elements. So we're going to initialize that to 0. So that's it. So our table has been initialized. So as we discussed, you only need these 3. So that's what we're going to initialize with. And now we're going to just say table 0 is 0, table 1 is 1, table 2 is 1. So we're going to initialize these. And I'm going to start a loop. Now this loop goes from 3 to n plus 1. Right? Now what we're going to do is we're going to calculate the modulus. So if I percent 3 is equal to 0, I'm going to say table of 0 is table 0 plus table 1 plus table 2. Else, if I percent 3 is 1, then we do the same thing, but then store it in table of 1. So instead of 0, I put it in 1. And then similarly, if I percent 3 is 2, I'm going to store this in 2. And that's it. Our table will be calculated. And when we are returning the value, we do the same computation. If n percent 3 is 0, my value is going to be residing in table of 0. So if I go back to the whiteboard, if n percent 3, so if I'm given n is 3, so n 3% 3 is 0, this value 2 is going to be sitting right here. If it's 4, n is equal to 4, n percent 4 or 4% 3 is 1, that value is going to be sitting right here. If I'm given a value of 5, 5% 3 is 2, the value will be sitting right here. So that's all I have to return. So I will do this, and then I will also do else if n percent 3 is equal to 1, return table of 1. Leave some space here just for readability. Else if n percent 3 is equal to 2, return table of 2. And that's it. So now we can run our code. So the test case was 4, so I can try with the edge cases. I can add 1 here, gives me 1. I can add 2, which again gives me 1. And then I can add 5, which we calculated as a value 7. And then we keep going, 6, value is 13, which is what we calculated. N is 6, value is 13. And so on. So if I just keep going, 7, and then if I try an arbitrary number like 24, so it just came out with a value. Now I'm going to go ahead and submit the code. And there we go. The code has been submitted. And the time and the space complexity. So for time complexity is actually O of 1 because there are only 38 values of n. Space complexity is actually also O of 1 because we only created a list or an array with 3 elements. And that's it. That's the solution. So thank you all for watching.